Welcome back to the Grand Solar Minimum channel. Today is June 1st, 2025. Thank you for tuning into this Sunday morning broadcast. Let's get started with our space weather stats right now. Solar winds have been pretty high all morning, actually. We've been seeing them fluctuate between the 990s and into the 1072 range. Right now, currently, before we started the show, we had hit 1008.1 kilometers per second with a density of 0.52. So a little bit of refresher here. If some of you who are new to this channel, some of you may already know this, but when we get high, very high solar winds, that pushes away a lot of the cosmic rays, the dust, the particles around Earth's orbits. At first, we'll get an influx of and get bombarded from all the particles that were already around Earth's atmosphere. But the density of the solar particles when winds are going at this speed are almost like nothing. In fact, this is as close to zero. Well, actually, we were at a 0.18 when I started doing the show prep. So, light density, just because when you see solar winds this fast, it thins out the particles that are already just hanging around Earth's magnetosphere, and then whatever particles that came from the CME also are here just as quick as the solar wind blows. And then after that, for a while, we're going to continue to see that density remain low. But what would be concerning would be if we had a density of 10 with this kind of solar wind. Now you're talking about a heavy strain of highly charged particles on electronics, satellites, and of course, with what we're already facing right now, that would cause some major disruptions if we had a higher density of solar particles infiltrating the magnetosphere right now. So thankfully that we are looking at a very thin density. Nonetheless, our sunspot number is coming back down. We are now at 96, and I'll show you why I think next week we will be in the low 50s, maybe below that when it comes to smooth sunspot numbers. I'll get to that here in a bit. We haven't had a spotless day yet, but I feel like this year might be the first one we see. Even though it's not officially the minimum yet, you always get that one day right before the maximum completely falls apart. And then after that, you have minimum conditions. And I'll show you exactly where we are as far as the solar cycle here just in a bit, as I plan to show you guys an update of where we are in solar cycle 25. But I wanted to talk about this recent weather news from the sun. And we are looking at some pretty impressive stats right now. This was just an M.8 or an M8 solar flare that made this eruption here. If you look in the middle of your screen, I will grab, or I thought I would. Let's see here. There it is. So this right here, I've got the arrow focused on that sunspot that kind of blew that flare yesterday. The thing about this outer edge of the coronal hole, when this explosion happens, it makes this coronal hole a little bit bigger temporarily. So that was a powerful release yesterday, or I'm sorry, Friday, that we saw from this sunspot here. Earth facing as well when this happened. This is not going to be a direct shot, but it's going to be pretty darn close. So thankfully it's not an X-class flare, but it wasn't very far from an X-class flare. Right now our KP indice is sitting at a 7.3 with a 24-hour max of an 8. And actually, we can go update that here in a second. I believe we are now in a KP 8 as our geomagnetic storm is continuing. It's at a G3 right now, but now we're looking at conditions that favor a G4. Our TSI is almost the same as it was, as much as we saw it go up and down over the past few weeks. 1362.7 watts per square meter is our TSI stats for now. The last time we did a broadcast was all the way back in April, and TSI was 1362.6 watts per square meter. So not much change with TSI, although if you look at it over the past couple of weeks, we have seen a couple of lower readings, but quickly rebounded back to 1362. 25% chance today of X-class flares, so we still have to pay attention to AR 4100. It is the largest sunspot right now that we're dealing with, and it's already let off an M8.4 solar flare, and now we are watching it to see if, especially right now, we're definitely watching it. A 25% chance of an X-class flare, if I could talk, explosion. With a 25% chance, that seems likely. So we are definitely on alert right now, and we will continue to monitor this as we're just now dealing with the effects from that release back on Friday. And we'll get more into that here just in a second. Let's go ahead and take a look at some stats. Sorry for the motorcycles in the background. We are having a type of a festival that we usually have here in the Lake George area. Americade is going on this week into the weekend, so if you guys are in the Northeast and you like motorcycles, come on out to Lake George's Americade, one of the biggest bike festivals. Not as big as Sturgis, but still pretty big. All right, so this is the TSI graph I was telling you about, and the last time we did a broadcast was right about where the TSI was, right about here. So pretty average. We didn't see a spike and then a huge drop in TSI. But I want to note, when we saw this huge drop in TSI, we had a sunspot number of 52, I believe. So the reason why this is important to mention is that when you have low sunspot numbers, you also have low facula. Now, what is facula? Well, I'll show you real quick. We'll go back to Space Weather Station. Facula is this bright light stuff around the sunspots. That really bright white material there, that's called facula. The sunspots are dark cores, which y'all know that. But when the sun is blank and we don't see facula, you will also notice that TSI is lower. Not obvious because the sun's weaker in its solar cycle, but when we have more facula, TSI improves, or goes up, I should say. And when we have less facula, that's less output for the sun. That's another reason why we've seen some record warmth temperatures over the past 2 years. Part of it is from the maximum output from the sun. It's been a little stronger than what was predicted originally, but not much, and I'll show you here in a minute. And then you couple that with all of the moisture, the record moisture that we have in our atmosphere from the 2022 eruption of Tonga. I mean, off the charts moisture in places of the atmosphere. I don't know if it's how long it's been. It's probably been thousands of years since we've seen that kind of saturation of moisture. I mean, it was off the charts, guys. So couple that in, higher TSI means more output from the sun, which entails more energy for Earth, and of course reacts as temperature rise, along with you have record amounts of moisture that isn't usually there, and it also helped warm up the atmosphere once that sun particles drive through those droplets. You will definitely see a temperature rise. Let's kind of think of it like this, like a magnifying glass. These water droplets are like a magnifying glass, and the sun is peering through them. So the sun's energy is going to be a little bit stronger peering through these moisture droplets in the higher atmosphere. And I believe that's why we saw that spike in temperatures over 23 and 24. Sorry. All right. Take a pause real quick. Okay, sorry about that. Miles was being demanding, so I had to put him on the couch. He's being a bad boy. Anyway, back to what I was talking about. Higher facula is higher TSI, can lead to warmer temperatures when it comes to Earth's climate. They connect lower solar activity to cooler times as well. And there's multiple reasons. Obviously, when the sun's TSI goes down, so will the temperatures. But when the sun's strength also reduces, you're talking about a weaker magnetosphere allowing more cosmic radiation dosage rates, which leads to cloud nucleation. Cloud nucleation turns into cloud coverage. That also has an effect on temperatures here at the surface. So you have a weaker sun, which entails into a weaker magnetosphere, which allows particles that will interact with our atmosphere to increase cooling. So the more particles we get in our atmosphere, the cooler our temperatures will get. And where we're heading at in this cycle, there's a lot of interesting things getting ready to line up to happen. Now, I know we've had people on here and say that we are in a grand solar minimum right now. We are in the very beginning stages of that grand solar minimum. I think we might have jumped the gun as far as when we'd see the stronger effects of the grand solar minimum, but I believe that we always have stated that we would see a grand solar minimum really take hold in the 2030s. And that's exactly where our our data is leading to us. Let's take a look at the overall picture. This is a TSI graph, and this also shows us that we are past that peak that was right here, and now we are on the downside. How much longer till we start the minimum of the TSI? Well, according to this graph, it might be another year and a half. But Zarkova and a few others have predicted a sharp decline at some point in solar cycle 25, possibly solar cycle 26. Here's another reason why I believe we will see some very low sunspot numbers moving into next week, into the week following. This is right now. This is Earth facing. This is the far side of the sun. And you can see we have some very little specks. In fact, let me try to zoom this in a little bit, make it a little more visual. Is it going to let me? It sure ain't. Well, if you guys want to take a look at this on spaceweatherlive.com, you can see this information. But if I had to take an educated guess, we could see sunspot numbers as low as 35, maybe lower. So that will be interesting to check out next week as we see a much quieter sun, possibly. If this graph is correct, we most certainly will see that. So let's take another look at solar cycle 25 and where we are now, and then we'll get back to the auroras. Everybody's talking about the solar winds. Right now, let's take a look at current solar winds as we go through the show. We're down to 990.5 kilometers per second. So thank you, Space Weather Live. And they are also saying we are observed KP8, which is a G4. Now, this is a severe geomagnetic storm. Any stronger than that, and we could seriously see some beautiful auroras tonight. And a lot of us are going to get a chance to see that as well. Very interesting, Melody. I just seen your comment in the chat. Last time we had a day without sunspots was in June of 2022. I wonder how close that was to Tonga erupting. If somebody wants to search that real quick while we're on the air, that'd be awesome. Kind of see the comparison of how also scientists believe that low solar activity triggers seismic activity, and this includes volcanic eruptions. So, Melody or somebody, let's come up with that date there. It'd be awesome. Here's what we're looking at. Our solar cycle 25 right now. I'll get our handy dandy little arrow out. And there's our peak. This is where we are right now. So clearly we have passed the peak of 25. Now, if Zarkova is correct, This line that is shown right here in the deep purple, that is the likelihood or even maybe a little bit faster of a decline. But the deep purple line here in the middle is closer to Zarkovas. Now, this orange line right here is what they think is going to happen. So, and look at that. Their minimum stops uh, in a range of between 50 and 100 sunspots when it comes to SSN, smooth sunspot number. So interesting how they believe that when we do get to minimum time, that it's not going to be a spotless sun. So very interesting. Things are going to get really interesting, and we're going to see before 2030 if that's true or not. Like right now, I feel like with this line being right here, we're actually, guys, I'm going to take a closer look at this, but wow. So what I'm looking at right now, the blue line that goes across this graph. Let's see if I can zoom this in a little bit. See, how does that look for you guys? Is that better? It's a little better. So there's two lines that are interesting to me in this graph. The blue line is what's been observed. The pink line is a possibility, a forecast track, and then the dark purple line is an indicator of what we could see, predicted sunspot numbers as we head towards our minimum. Now, you see, as we go all the way down here, we get to 2030, we will be in a minimum by then. We're seeing sunspot numbers very low, of course, 0 to 14 by 2030. Now, if we follow this pink line, sunspot numbers will decline faster and get even lower before 2030. Look at that. Right before we hit the minimum in 2030. And then again, we're talking 0 sunspots, 2030s and beyond. So what I believe that we're going to see, and this is the immediate prediction, is this bright red right here. Okay, so that line right there is what they're predicting immediately. If I had to, I think the safest prediction line to watch is the dark purple one, but also the one I think that favors more Zarkova's forecast is the bright pink one just below that purple. That's where we see a faster decline. I mean, right now everything's in play as far as the decline. Or now when it comes to this orange line, that's just ridiculous. They're saying, whoever's got this idea of the orange line here, 70.5 as a smooth sunspot number for the minimum past 2030. That would be extraordinary. That would be groundbreaking, because as us amateur scientists here who follow cycles and know that the grand solar minimum cycle happens every 350 to 415 years approximately, right? So if this orange line is correct, wow, what a huge shift that would be in what we thought, right? But right now, I don't see any evidence that would take us on this trip here along this orange line. I think it's going to be more this bright pink line here that's just below the purple, and we'll continue to see it decline as we hit 2030. We will know we are in a minimum definitely by 2029, 2028, late 28. But we will start to see conditions on the sun decline rapidly. No one's taken in the consideration of a sharp decline, which would put us in a minimum by 2027. And Zarkova's model kind of suggests a sharp decline as sharp as that. So again, that's not even in the spectrum right now. They're not even considering that. The outer line for the sharpest decline is that very outside line here. and it still doesn't have us at 0 before 2030. So a few others in Zarkova do have models that have us quickly declining out of this cycle. Minimum definitely will be in the 2028 to 2030 range, but could it be sooner? It'd be interesting watching the rest of this progression of this cycle, or I should say declination, because we are in a later part of cycle 25. Everything else lines up with where we're supposed to be. Oh, this was another graph I wanted to share. So, along with the sunspot numbers peaking a little higher than what we predicted, it's interesting to see that this solar cycle has put out the most amount of flares. Now, is this an indication of the sun waking up out of this historic pattern of cycle that we've seen for years? And some of you have, this is convincing evidence, right? But let's look at the last 4 years starting from now. Look at the sharp decline that we're having. I know it's only halfway through 2025, but halfway through 2025, we're already slated to maybe finish with the number of C, M, and X class flares somewhere in the 80s, which would be a 2-year drop from levels that we saw in 2022. Also, if you look at solar cycle 24, we never got past 80 when it came to that amount of C, M, and X class flares. So it's interesting to see the strong start to solar cycle 25 when it comes to the flares, but how quickly we are starting to see things kind of drop and drop fast. Halfway through 2024, we were looking at already over 85, maybe right at the 80 mark for sunspot, or I'm sorry, flares, C, M's, and X's, and finished near 160 altogether for 24. 25 is not going to be anywhere near that. And this is also during 23 and 24, we were seeing the peak of the cycle was growing further higher, and now that the peak is over, we're going to start seeing that reflected here in the next several months, especially right now what we're looking at. Again, number of flares last month, they are on the rise from the beginning of the month. And at the end, we've kind of had this sharp increase of flares. The sun has had quite a few flares here as of lately. An awesome detail here by spaceweatherlive.com. I'm a big numbers guy anyway, but so, seeing graphs like this really gets me excited. So here's how we know that we had a stronger cycle than we've had in previous years. And it's the amount of, I'm sorry, this is the spotless days. So look at how much weaker cycles. 23 and 24 literally mocked each other. So it'll be interesting to see how 25 pairs out. Everyone's talking about how strong of a solar cycle this is. We will see how weak it is if it keeps this same energy, this grand solar minimum energy, I should say, moving forward. But there wasn't. Here it is. This is another sign that the sun is getting weaker. Wow, I'm rusty, guys. I apologize. Sheesh. Good Lord. January 15th, spotless day was on June 8th. Don't know what to. Okay. So they are not anywhere close to each other whatsoever. But still, was just curious. But thank you, Melody, for doing the homework there. I appreciate that. See, we don't have lazy people. Tango Man, also, thank you very much. Appreciate the research on that. Reverend Fry, how many spotless days between 24 and 25? Well, we don't know yet for 25, but we do know for 24. Solar cycle 24 right here. See, here's our spotless days for solar cycle 24. Here's 23. 25, we haven't even gotten to our minimum yet, so we don't have any. But as you can see, 23, I think 24 was slightly weaker when it comes to sunspots. Slightly, not by much. Um, but we see these 2 years right here where we had spotless days a lot, and then this kind of makes up for that. So it's kind of hard to average it out, but I think on the average, solar cycle 24 was slightly weaker when it comes to spotless days. We had more spotless days in solar cycle 24, and like I said, solar cycle 25 is beginning to start its decline. So we will see. Spotless days maybe not too far away, maybe late this year, maybe early in 2026. But here's another sign that the sun is getting weaker as well. Geomagnetic storms. Look at how much fewer we've had. This trend is not reflecting a cycle increase on the way. This seems to me this was our modern maximum right here of when it comes to geomagnetic storms. Now, there's a couple of things. This is kind of cheating a little bit because geomagnetic storms, a lot of them can happen during solar minimums, meaning if the magnetosphere is weak enough and we get big giant coronal holes, we'll get solar winds and we can get G3s and G2s and all that. So, but the point I'm trying to make here is that we're not seeing the volume of geomagnetic storms like we see in the 80s when the sun was much stronger, and 90s and early 2000s. But then you look back, well, what happened in the 50s and 60s and 70s? Well, that's the other effect of low solar activity, low magnetosphere, which created more possibilities for geomagnetic storms when we had large coronal holes. So it's kind of deceiving, but at the same time, it's also obvious how much decline we've had in geomagnetic storms over the past 2 cycles. To me, that is just indicating a weaker sun. Let's move along. And guys, thank you so much. SpaceWeatherLive.com. Really putting in the time and the work. And I think these facts are important to see. Whether they favor what we stand for or not, these kind of are neutral. You could say on a couple of these graphs that the cycle got stronger in May. And then you could say that, the amount of flares have increased in this cycle, but now we are starting to see a sharp decline, the same decline we are seeing here in sunspots. Right here. So it all is lining up. Time will tell. I really believe that solar wind speeds, by the way, are starting to drop a little bit, which is good. But this storm will not be over anytime soon. Back to that. We're going to have a pretty good chances of auroras for the majority of us here in the northern half of the United States. G4, I'm looking for a map. That shows us where we're going to see these bad boys today. You'd think one of these guys would have one. How about space weather? They're all over your social media feed, I tell you that. Facebook especially. Let's update this. Solar wind speeds down to 977.7 kilometers per second. Density is at 0.43, almost unchanged. Cosmic radiation dosage rates too, I forgot to talk about that. Those are pretty moderate right now, nothing crazy. But imagine if we had dosage rates of that of a minimum. It would be a much much more intense storm for sure. All right. Well, I can't find the graphic, but I do know that a lot of us across the Northeast, the Ohio Valley, into the northern plain states, across Montana, Wyoming, Washington, we have a pretty good chance of seeing some auroras tonight if the the Canada smoke doesn't block it, or possibly even in the Ohio Valley as well. Yeah, that might be affecting your view tonight as well. Yeah, so that's our update for the current storm that we are in. We are a KP8. That is a G4, a very severe geomagnetic. I don't know about you guys, but I'm experiencing ringing of the ear like nobody else. Okay. Lisa Ann Hart, you say that the peak of solar maximum will be at 2030. Expect more volcanic activity, maybe a VEI 7 in the start of the year without a summer. Well, those are some bold predictions. First of all, I think you probably meant solar minimum, the peak of solar minimum, which you are correct about that. Um, I'll tell you what nobody's talking about, Lisa. Um, that's the new Madrid fault line. And we've seen multiple earthquakes, minor ones across the region here recently that have increased. And it's starting to make people a little nervous, especially people that live in Ohio that aren't used to feeling earthquakes. They're little ones, 3.5s, 3.4s, maybe a 4. Here in the Northeast, we've had some earthquake action down in Middle Tennessee, 4.8 not too long ago, Eastern Tennessee. So, the New Madrid fault line is something I would watch as well for the 2030s. VEI 7 or 8, those are the kind of events that can cause global cooling in an instant. You're talking about by 2040, we'll be looking at a mini ice age if we get a VEI 7 or a VEI 8. So it's a possibility. Like we talked about earlier in the show, lower solar activity creates seismic activity, earthquake and volcanic activity. So we'll just have to see how weak the sun actually gets to see something as strong as a VEI 7 or a VEI 8. I don't want to be that guy that calls that prediction just because that's not going to be a fun time for any of us. And that's worrying and concerning. Here's another look at that awesome Halo CME that we had on the 30th. Here's the 28th, 29th. And here comes the 30th. Interesting enough, I believe that's Venus. And as Venus and the sun cross paths, boom, we see this CME, the halo of it anyway. Very strong. The blast lasted for 3 hours. Yep. So, interesting times. We're not even near the minimum yet. We're still kind of hanging around the lower parts of the max. But if you've noticed, we haven't seen sunspot numbers over 140 in a few weeks. And I believe that number is going to continue to drop. And that's going to be the telling part of how fast we are declining and how fast we're not. So time will tell, like we've always said on this channel. But time is, in my opinion, everything that we've talked about has come true. Short, hot summers, long, cold winters, hail like we've never seen before. Hello? Have you guys seen the hail footage so far this year? Insane. We had one region that had 6.5-inch diameter hail. That's softball size or bigger. Austin got destroyed with hail not too long ago. You better believe that's destroyed some crops along with some roofs, windshields, car hoods. I mean, that kind of hail used to be talked about once in a decade. And every year now, we are seeing more and more frequent headlines of this huge hail, this dynamic hailstorm that makes it look like snow just fell. Insane. So everything we've talked about, I feel like, has come true. And a lot of the stuff that we base our information on is from PhD scientists like Valentina Sarkova. She is a PhD in astrophysics and mathematics. Mr. John Casey, who was the head of his own volcanic earthquake research center. and studies the grand solar minimum and solar cycles. He's also the one that's helped us identify seismic activity as connected to the sun. If you haven't read the book Upheaval, I highly recommend it. Everything that you've heard in this show is going to sound familiar to you when you read this book. And it's going to help you understand what John was trying to say when this book came out originally, I think 2019. So if you've been a long time viewer of this channel, chances are you have watched or read the book already. If you haven't read the book, please do. You're going to learn a lot. And a lot of the things that we talk about on this channel when we do go live is going to make a whole lot more sense to you without having to paint the picture. All right, I wanted to show you guys this real quick since we're talking about solar storms and all that good stuff. The strongest one ever recorded in over here on watchers.com, the Watchers, or I'm sorry, watchers.news. I always butcher this guy's website. I'm so sorry. I mean no disrespect. Me and Teo and Mari, we all go way back, so we love this guy. But anyway, so a new study found that a massive solar storm that struck Earth over 14,000 years ago has been identified the strongest ever recorded. Traces of the event were discovered in ancient tree rings, revealing a sharp spike in radiocarbon levels in 12,350 BC. The finding extends the known limits of solar activity and provides a rare reference point for dating events in the late glacial period. Now, that's important. This finding extends the known limits of solar activity, solar storms. So right now, the strongest storm that we could have is a G5. Is this study suggesting that this storm that was 14,000 years ago was a G6 or stronger even? Let's read on a little bit here. I won't do the whole thing, but there's some important things in here. An international team of researchers has identified the strongest solar particle event ever recorded back in 12,350 BC. The discovery was made by detecting sharp increase of radiocarbon levels preserved in ancient tree rings. This research team developed a new chemistry climate model named Solar Climate Ozone Links. So here's another story of solar activity having a role in climate models. Carbon-14 extended, so-called 14CX, that's for short. The model simulates how high-energy solar particles interact with Earth's atmosphere under varying climatic and geomagnetic conditions. Previous models were largely limited to the stable conditions of the Holocene, but this version allows simulations during glacial periods as well. Blah, blah, blah. Let's see. The one before this, what was considered the strongest ever, was 775 AD, but this one was about 18% stronger than that, the one back in 12,350 BC. The radiocarbon spike reached about 37%, nearly twice the 20% recorded in 775 event. This might seem to point to a much stronger solar outburst, but the team found the difference mostly reflects glacial air conditions like lower carbon dioxide, a weaker magnetic field, and that's very important that they're including that, different air circulation as well. So why would there be lower carbon dioxide with a weaker magnetic field? And simple. Weaker magnetic field allows more particles to interact in the atmosphere. Weaker magnetosphere also suggests that we had weak solar output, which caused cooler conditions. And when you have cooler conditions, you don't have the plant vegetation, the growth that you have, like we have right now. And CO2 limits are not even that high compared to where they've been before in history. So with events like this, you had less CO2, less growth of vegetation during a cooler period of time. So just think about how much lower CO2 was when you don't have trees out there like we do now, taking it out of the atmosphere. The team modeled how carbon-14 was produced and moved through the atmosphere after the SEP, which is they just set it up here, didn't they? I'm already dropping the ball with their their abbreviations. Oh my gosh. So they based it on the shape of a 2005 ground level enhancement 16 number GLE 69 solar storm, but boosted its scale over 500 times. They estimated the timing of the event that came between January and April of 12,350 BC. This finding sets a new upper limit for solar storm strength and also opens the door to refining radiocarbon dating earlier than previously stated the Holocene. Since tree ring records become less certain deeper in time, a worldwide carbon-14 spike like this gives a rare reference point for aligning and calibrating ancient timelines. Interesting. This is the first confirmed solar event of its kind of the Holocene epoch. It expands our historical knowledge of solar activity and offers a new reference point for research moving forward. The solar storm occurred during the late glacial period, a relatively warm phase following the last glacial maximum. The interval was characterized as rapid warming, widespread glacier retreat, and rising sea levels across many regions. Check it out on watchers.news. I just thought there were some interesting points in here. And again, when we talk about the science of these older data sets, the tree rings, the ice cores, the sediments, all these things play a major role in finding out this information. So, good study here, good article on watchers.news. Thank you very much for that. And let's take a look at our tropical tidbits really quick before we do one more update on the sun, too. We do have what looks to be here the last couple days. We've seen what could be our first hurricane landfall of the year. And of course, they have. I hate it when this happens. I had this set up earlier and they were showing me all the way into June 15th. Now it doesn't want to go past tomorrow. Well, that's a bummer, but we do have a system that is tracking west now. It was closer to the Tampa Bay area and going up the East Coast. Now, and I'll show you where the path's going to be at least. And this is a storm that will be in the 900 millibars. And originally we had it here in the Tampa Bay, the Panhandle area, the Gulf of America, and then it goes up the East Coast and heads out in the Northeast. Now this system is tracking closer to Mississippi, Alabama, and making its curve in the Ohio Valley, still coming through New York, but basically the capital region and south because it takes a hook and goes off to the Atlantic. So right now the model is trending west, and usually once you start seeing a more track to one way or the other, that's the way it's going to be. I haven't seen this track west yet, so let's see if this continues over the next couple of days. But we're 14 days out. We still got plenty of time for it. Unfortunate that Tropical Tidbits here is, well, let's do this. You know who's going to have this on his page? Mike's. Good old Mike's weather page. He's got all the cool graphics here. It's not showing up in his radar yet either. So still really early. Well, that's too bad, guys. I was hoping to have a map or some kind of indication of the storm, the water temperature. However, let's take a look at those and see where they're favorable. So right now we're in the low 80s in most of the area. So this storm shouldn't be more than a Cat 1, to be honest with you, and then turn into a tropical depression once it makes landfall. So nothing major here. It could be a tropical depression all the way. This is the area that we're going to be focusing on right now, coming up through here into warmer waters, but not super hot. So right now temperatures are higher than what they normally are at this time, but still not hot enough to fuel a monster storm at this time. So we'll keep our eyes on that. Like I said, that's 2 weeks away, but it's crazy because last year on June 1st, we weren't talking about hurricanes. We were talking about, yes, CO2 discharges. Thank you for correcting me on that there, Melody. I apologize. I got my words mixed up. That happens. But last year, we weren't talking about hurricanes till July, late July. Like it started off very, very, very quiet. Picked up a little bit in August, but nothing crazy. So this year, we are seeing it starting up just a little bit earlier than what we have had in past seasons. Let's take a look at the sun one more time. Actually, I want to go and verify solar wind speeds. Still coming in at 976 kilometers per second. Previously, before the show had started, we had a solar wind speed of as high as 1,072 kilometers per second. So it is still relatively high, even at 976 kilometers per second. That's still very high. It's over 1.5 million miles. I know that. I know at 1,000 kilometers per second, we're also talking about 2.5 million miles per hour. So just to kind of give you an idea how fast the solar wind is coming in, it's very extreme. Solar wind this fast definitely causes geomagnetic storms. But we'll keep our eyes on our skies as we will possibly see some beautiful aurora across most of the northern part of the United States, dipping all the way down in the Ohio Valley. Keep your eyes open. Hopefully you don't have too much cloud or smoke blocking your view tonight as well. All right, so say hello to everybody out there in the chat. Knife Collector, great to see you on today. Melody, good to see you. Jerome, my fellow New Yorker, good to see you out here as well. Reverend Fry, a familiar face. Lisa B, nice to see you. Hello there to George. And many, many other people out here. Lisa Ann Hart. We have a Lisa B and a Lisa Ann Hart. And a few other new faces out here. So welcome to our show. And again, it's been spotty on our broadcast, and we're trying to cover the bigger events. Of obviously, once we start getting later into this year, there are probably going to be more broadcasts moving forward just because of the solar activity. Even though we're heading away from a maximum, we still have a lot to watch here, especially the seismic activity. So that side. All right. So with that being said, thank you for tuning in once again to the Grand Solar Minimum channel. We hope everybody has a great Sunday, and we will talk soon. Take care, everybody.
Do you like this show? Give us a thumbs up. Want to support us more? Share to your favorite social media platform. Buy a t-shirt.